If you've been keeping an eye on AI, you know something big has been happening. There's been a massive shift. We've gone from just asking AI questions to actually giving it goals, and then watching it figure out how to get there, all by itself. So let's get right into this. Let's talk about the evolution from AI as a tool to AI as an agent. This slide just lays it all out perfectly. On the left, that's the world we've been living in. You ask a question, you get an answer. Simple, linear. But look at the right. That's where we are now. You give the AI a high-level goal, and the agent, it goes out and navigates all the messy steps, the searches, the API calls, whatever it takes to deliver a real outcome. It's a huge move from just following instructions to actually solving problems on its own. So what even is an agent? Well, the word itself comes from the Latin agere, which literally means to act. And technically, your thermostat is an agent. It senses the temperature and it acts. But what we're talking about today, that's a whole different ballgame. A modern AI agent has a large language model, an LLM, as its reasoning engine. It's the brain. And that allows it to perceive, reason, and act in ways that are just so much more dynamic.
So how do you build one of these things? Well, it turns out that pretty much every agent, no matter how complicated, is built on 4 key pillars: perception, memory, planning, and action. You can really think of these as the basic cognitive functions that any intelligent system needs to work autonomously. Let's break each one down.
First up, we've got perception. Pretty straightforward, right? This is all about how the agent takes in information from its world. It's basically the agent's senses. And in the digital world, those senses can be incredibly powerful and diverse.
And this gives you a little taste of just how broad that perception really is. An agent isn't just reading your text prompt. No way. It's looking at API responses, it's scraping websites, it's understanding the output from its own tools, and it's even checking on the state of a system. And here's the key challenge. What really separates a good agent from a great one? All this real-world information is messy. It's ambiguous, and the agent has to be smart enough to make sense of it all.
Okay, so let's move on to the next 2 pillars, which really form the cognitive core of the agent: memory and planning. If perception is the senses, this is the brain at work. It's how an agent remembers what it's done and then decides what to do next to actually hit its goal. And this is so crucial. Agents rely on 2 completely different kinds of memory. You've got working memory, which is short-term. It's all the info that's right there in the context window for the task at hand. But then you have long-term memory. This is usually stored in some external database, and it lets the agent remember things from way back, giving it continuity and letting it actually learn from experience. And that brings us to the final pillar: action. Honestly, this is the real game changer. This is what separates a passive system, a thinker, from a true agent, a doer. An agent doesn't just give you text back. It takes actions that have real effects on the world. But here's the thing, not all actions carry the same weight. As you can see here, there's a clear hierarchy of risk. Just retrieving some information, that's low risk. But sending an email on your behalf, that's high risk. It's hard to take that back. And directly interacting with a system, that's very high risk. So any well-designed agent absolutely has to have guardrails in place, demanding more checks and balances for those bigger, more permanent actions. So how do all these pillars, perception, planning, action, how do they all work together? Well, they form this continuous cycle we call the agent loop. The agent perceives the world, it plans its next move, it acts on that plan, and then, critically, it observes the result. It then evaluates if it's getting closer to its goal, and then it repeats the whole thing over and over. This loop is the fundamental rhythm for how any autonomous agent works. And what's sitting right at the absolute center of this whole process, driving every single step? The large language model. The LLM is the brain. It's the reasoning engine that's doing all the heavy lifting. The planning, the interpreting, the deciding. Everything else in the agent's architecture is really just there to feed information to this core and to carry out its commands. So how does this thinking actually happen inside the LLM? Well, the foundational idea is this deceptively simple but incredibly powerful framework called REACT. It stands for reason and act. And the core idea is just that. The model literally mixes its reasoning, its thoughts, with the actions it's about to take. And check this out. Here's what it looks like in practice. It's so brilliant. First, the agent has a thought. Okay, I need to find the population of Brazil. Then it chooses an action, like running a web search. And finally, it makes an observation based on the result.
This cycle makes the agent's logic totally transparent and lets it change its plan on the fly as new information comes in. You know, an agent is only as good as its tools. It's got this tool belt, and on it are things like a web search tool, a code interpreter, maybe a way to query a database. But here's the really important part for anyone building these. The LLM only decides which tool to use and how to use it. It's your application that actually runs the tool. That separation gives you all the control and all the safety. Okay, let's take a breath here for a quick reality check, because while all this is incredible and the hype is definitely real, we have to be honest. Today's agents are still brittle. They're impressive for sure, but they can break pretty easily. And they tend to fail in some pretty predictable ways. They can get stuck in loops doing the same thing over and over. They can totally misunderstand what you actually wanted. They can hallucinate facts, or they can just make a bad call about which tool to use. Building a reliable, production-ready agent is still genuinely hard work, and a lot of it is about engineering around these exact failure points. So, where is this all going? What's next? Well, the next big frontier is moving past these single do-it-all agents. The real power, the real explosion in capability is going to come from creating ecosystems of specialized agents that can work together, delegate tasks to each other, and solve problems that are way too complex for any one agent to handle alone. And that really brings us to the final big picture question. Is this whole shift from a simple tool to an autonomous agent just another technical update, just another step forward? Or are we actually watching, right now, the creation of the fundamental building blocks for the next major computing platform, one that's going to totally change how we interact with technology itself?